All right, we're back for example 4. So we're going to be using CPCTC in the coordinate plane. So this is a coordinate plane, right? What we're given is we're given just 3 points, D, E, F, and G, H, I. So these represent a triangle and these represent a triangle, and we need to prove that these two angles, DEF, is congruent to GHI, okay? So first thing I'm going to do is just go ahead and plot these points. So the first one is D, -5, -5, so that would be right about here, -5, -5. Then E, -3, -1, and then F, -2, 3. I don't know about that. I'm going to plot this other one. I bet you I messed up. Because maybe it is. That triangle is like that. Such a weird looking triangle. I'm going to plot this first just to see. -2, 1. -2, 1. I'm going to do a different color. Obvious. I need obvious. Let's go blue. Okay, so -2, 1. And then H would be 0, 5. And 1, 3. So 1, 3. Yeah. Okay, so that's what this triangle looks like here. And this is, what is this? -2, 1, that's G. And then this is H. How did I mess that up? 0, 5. Oh, it is right here. H. Okay, that's H. And then I is 1, 3. Okay. So we're supposed to be using CPCTC. I know that those triangles aren't right, so I'm pretty sure that this right here, this 3 is supposed to be a -3. And if we change that to a -3, right? -2, -3, then those two triangles now look like they would be right. D, this is D, this is E. I always like to do the points and make the triangles before I do the letters, because sometimes if I do a point and then do a letter, sometimes it's like the letters right on the line or whatever. So that's what I do just to make sure I can write the letters in a spot that isn't where the triangle is. And this is F. So make sure you make that a little adjustment, make that negative. I don't know, messed up on that. And you look at it, like 4.1, what would this be? I mean, we're going to do CPCTC, but this, I mean, these look like they're corresponding. It looks like that, and that looks like we have kind of like close to a right angle. It almost looks like it's a translation. Like if I go, up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, that would be the same. So up 6, 1, 2, 3, 4, 5, 6, over 3. Where was I? Right here. 1, 2, 3, yep, and then this one up 6, 1, 2, 3, 4, 5, 6, over 3, 1, 2, 3, yeah. So these are actually translations, so we could prove that they're congruent by just proving that they're a translation, right? However, that's not what we're doing here. I just saw that and it looked kind of cool. So we're doing a coordinate proof. So how we do a coordinate proof is we really have to show that. We just have to show that the distance of the sides, that's really all we have is the distance of the sides, and they have to be they all have to be the same. So that means a bunch of distance formulas. So distance formula here, distance formula here, distance formula here. So that's 3, and then 1, 2, 3. So we're going to have to do 6 distance formulas. From those 6 distance formulas, we're going to be able to prove that this triangle is congruent to that triangle by side to side. And then because those two triangles are congruent because of side to side, right? We know 3 pieces of information. That side to side unlocks the other 3 pieces of information, which just happen to be the angles, which is what we need to prove. We need to prove that DEF, which is this angle right here, is congruent to GHI, this angle right there. Okay? And so we'll be able to prove that by CPCTC. Corresponding parts of congruent triangles are congruent. Woo! Let's go. Let's get started. We got this. Okay, it's going to be a whole lot of distance formula. So you need to make sure you memorize this bad boy. Okay, I'm just going to start with this triangle. So DE, I'm going to, what am I going to do, Joy? What are you going to do? I'm going to label these, okay? I'm just going to write all the vertices out and label them first. I guess right here. So this is going to be D is -5, -5. E is going to be -3, -1. F is going to be -2, -3. And so I'm just going to call this my X1, Y1. This is going to be my first point. This is going to be my second point. And this is going to be my third point. Okay? And then what I'm going to do is I'm just going to write these other points over here. So G is going to be -2, 1. H is going to be 0, 5. And I is going to be 1, 3. And so I'll just call this this will be my fourth point. This will be my fifth point. This will be my sixth point. Okay, all right. Now we just got to start with the distance formula. So I'm going to do this triangle in this pen and that triangle in that pen just to kind of keep things separate a little bit. So DE, I'll do the first side here, DE. So we'll go DE first. Okay, it doesn't matter which one you do first, but that's what I'm doing. So DE is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? And then I'm going to substitute in. So what do we have? We have, what do we have? X2 is -3, so square root of -3 minus, that's a part of the equation, x1, which is -5, and that's all squared, plus y2, which is -1, minus y1, which is -5, squared, equals time to, what are we doing? Simplify. So those two negatives become positive, right? -3 plus 5 would be 2. So it's going to be 2 squared plus, those two negatives become positive. We got -1 plus 5, which would be 4 squared, right? That's going to be, what, 2 times 2 is 4, plus 4 times 2 is 16. So it's going to be 4 plus 16, okay? And that is going to be, I'm going to write it here, DE is equal to the square root of 20. And then we just need to put that in exact form, right? So we want to say, hey, is there a squared number that's a factor of 20? And remember, squared numbers, those are, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, right? These are all squared numbers. So 20, we know that 20 is the same thing as 4 times 5. So I can write that as the square root of 4 times the square root of 5. 4 times 5 is 20, right? And then the square root of 4 is 2. So it's 2 square roots of 5. So what that means is we know that DE, I would usually write it down here, but I got to do 6 of these, and I think I'm not going to have that much space. So I'm going to write DE is equal to 2 square roots of 5. So that's an exact form, and you're going to have to do that for this chapter, this section. Okay? Perfect. We got DE down, so I think I'm going to do the next one, which would be, okay, we have DE, so how about, well, let's go DF, okay? I'm going to use another shade of red just so it's a little different, but kind of still the same. I'm hoping, because it's going to be a little busy. So what did I say, DF? DF. Okay, so DF equals the square root of, okay, we got x1 and x3, so that's going to be x3, put a parenthesis, minus x1 squared plus y3 minus y1 squared. Okay. Now we're just going to substitute in. So x3 is negative 2 minus x1, negative 5, all of that squared. y3 is negative 3 minus y1, which is negative 5, and all of that squared. Then we simplify, right? So those two negatives become positive. Negative 2 plus 5 is 3, 3 squared, plus those two negatives become positive. Negative 3 plus 5 is 2 squared. And then what do we have? 3 squared is 9, plus 2 squared is 4, right? 2 times 2. And then just 9 plus 4 is what is it? What is it? What is it? It's 13. So we know that DF is equal to the square root of 13. And for this one, there's no squared numbers that are factors of 13. 13 is a prime number. So we know we're done there. Okay, so we have 3. One more for this triangle. And then we'll go back to this color because it's a shade of red. So what did we do? We did DE, DF. Now we have to do EF. So EF is going to be the square root of x3 minus x2 squared plus y3 minus y2 squared. Then we just substitute everything in. So x3 is negative 2 minus negative 3 squared plus y3 is negative 3 minus y2, which is negative 1 squared, equals, okay, simplify, right? So those two negatives become a positive. We got negative 2 plus 3, which is just 1 squared, plus those two negatives become a positive. We got negative 3 plus 1, which would be negative 2 squared, right? Equals 1 squared is the same thing as 1 times 1, which is 1. And then negative 2 squared, negative 2 times negative 2. Our answer is going to be positive. 2 times 2 is 4. So there we have it. EF is equal to the square root of 5. And that is something that we don't need to, what do we not need to do? We don't need to think. What do we not need to do? That's it. We don't need to simplify it any further because that's a prime number and there's no square numbers that are factors of 5. Okay, perfect. Now, so we have all of the sides for the first triangle right here, right? So we have one here, and one here. Now we just need to do the 3 sides for the blue triangle. Okay. So it doesn't matter which one we start with. Let's just start with one. How about just GH, okay? So GH is going to be, got to do the distance. So what is G? Oh, we got X. Okay, so it's going to be X5 minus X4 squared plus Y5 minus Y4 squared. Okay? And then we just substitute those values in. So X5 is 0. 0 minus X4 is negative 2. Plus Y5 is 5. Minus Y4 is 1 squared. And then we just simplify. So those two negatives become positive. Oh, sorry, I keep touching this and I keep jiggling. My bad. Those become positive, and then, yeah. So 0 plus 2 is just 2, 2 squared. Plus 5 minus 1 is 4, 4 squared. Which ends up being 2 squared. 2 times 2 is 4. 4 squared, 4 times 4 is 16. That ends up being square root of 20, right? And we already did the work up here, so we know that the square root of 20 is the same thing as 2 square roots of 5. So I'm just going to say GH is equal to 2 square roots of 5. Okay? And then, okay, so GH, let's do GI. I'm going to use just a different shade of blue. GI, oh, that's not an I at all, is it, Joy? It's going to be a little chunky I. There we go. So GI is equal to, okay, so x6 and x4. So it's going to be the square root of x6 minus x4 squared plus y6 minus y4 squared. And then we substitute in, okay, x6 is 1. So 1 minus x6 minus that, so negative 2 squared plus y6, which is 3, minus y4, which is 1 squared. And those two negatives become positive. We got 1 plus 2, which is 3. So square root of 3 plus 3 minus 1 was 2. Oh, wait, this is 3 squared, my bad. And then that's 2 squared. So, oh, that's squared. Why am I writing cubed? Okay, 3 squared. 3 times 3 is 9. Plus 2 times 2 is 4. So we end up with the square root of 13, right? So that's what GI is. Square root of 13. Okay, and then the last one, what did we do? We did GH, and then we did GI, so now we need to do HI. Okay, so I'm going to go back to my blue. HI is going to be the square root of, what is it? Oh, the 5 and the 4. So x5 minus x4 squared plus y5 minus y4 squared is going to equal, then we just substitute in, x5 is 0, so square root of 0 minus x4, which is negative 2, squared plus y5 is 5 minus y4, which is 1 squared, equals those two negatives become positive. 0 plus 2 is just 2, so we got 2 squared plus 5 minus 1 is 4, 4 squared. I feel like something's not right here. What isn't right? What did I do wrong? This is HI. Oh, that's what I did wrong. You guys are like, what are you doing? HI is not x5 and x4. It's x5 and x6. Oh, Nelly. Okay, sorry about that. I was probably totally confusing you guys. My bad. So let's do, okay, HI is x5 and x6. So I was doing this problem. What problem was I doing? I was doing this problem again. I was like, I'm going to get square root of 20. That's not going to be right. Okay, so my bad. So let's just start over. So it's going to be x6 minus x5. So how am I going to do this? I think I'm just going to have to white it out. Okay. This is the wonderful power of white out. Look at that. It just makes mistakes go away. Just going to go here, 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 here. Okay. So high is 6 and 5. I don't know how I messed that up. You guys are probably like, what are you doing? You're doing it wrong. Okay, so x6 minus x5. And this is going to be y6 minus y5 squared. Okay, then we square root and we plug in the numbers and x6. So that's going to be 1 minus x5, which is 0, squared plus y6, which is 3, minus 5 squared equals 1 minus 0 is just 1. So it's 1 squared plus 3 minus 5 is negative 2 squared equals, 1 times 1 is 1 plus negative 2 times negative 2 is 4. And there we have our square root of 5. Okay, cool. So HI is equal to the square root of 5. Perfect. So there I have my other 3 sides of values. And if you look, you can see that it looks like DE is congruent to GH. They're both 2 square roots of 5. DF is congruent to GI with square root of 13. And EF and high are congruent with square root of 5. So we have 3 sets of sides that are congruent, right? So we can say that these 2 triangles are congruent because of side to side. And what are we trying to prove? We're trying to prove that these angles are congruent, and we can totally do that because, let's see, let's mark it first. So what was it 2? So DE, so this side is congruent to GH, right? 2 square roots of 5, GH would be here, okay? And then square root of 13, DF is congruent to square root of GI, right? And then lastly, this one is congruent to this one. Okay, so this angle is between a 1 and a 3, a side that's a 1 and a 3. So for it to be the same angle, it has to be between the 2 sides. So this is between a 1 and 3. So we know that those 2 angles are congruent. So we got the 2 triangles that are congruent. We know that these are corresponding angles. So therefore, these angles are congruent because of CPCTC. So let's go ahead and write it in this cute little box right over here. So we have, what do we have? We have DE is congruent to GH. We have, I think I'm just going to do a little something here just to, okay. And then the 2, DF, is congruent to GI. Oh, I need a line segment. And then the 3, EF, is segment EF is congruent to high, HI. And then because of that, we can say that triangle, I'll start with D, okay? So it's between a 1 and a 2, and I'm going to go in the direction of 1, why not? So DEF is congruent to, okay, I got to find the angle that is between the 1 and the 2. The 1 and the 2 is here, so that's G. And I went in the direction DE, so I went in the direction of the side that has a 1 hash mark. So that means here, G, I'm going to have to go to the side that has a 1 hash mark, which would be H, I. And I can say that those 2 triangles are congruent because of side, side, side. Therefore, angle DEF is congruent to angle GHI because of CPCTC. Boom! There you have it. That is example 4. So we had all of the 6 distance formulas. We put them into exact form. Then we said that, hey, because of the distance formulas, we know that these 3 sets of corresponding sides are congruent because of side, side, side. Therefore, we can prove that this angle is congruent because of CPCTC. Congruent parts of congruent triangles are congruent. Okay, now we're going to go ahead and check it out, example 4. So I actually want you to go have some time and try to work on this coordinate proof on your own. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out this problem. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. Okay, what do we have? We're given 3 vertices here and here. That's a triangle, that's a triangle. We got to prove that 2 angles are congruent. So the first thing I'm going to do is just go ahead and graph these vertices. So -1, -2 right there. K is 2, -1 right here. L is -2, 0 here. So I have this triangle. Okay, this is J, this is K, and this is L. Okay, now I'm going to go ahead and graph the other triangle, which is 2, 3 here, 5, 2 here, and 1, 1. So we have this lovely triangle here, and this was R, this was S, and this is T. And so the angles that they're asking for are JKL, this angle here, and RST, so this angle here. Ooh. Yeah, we want to prove that those are two congruent. So how'd you do it? So if I was doing this, I would probably show that a bunch of distance formulas, right? So distance formulas, you show 3 sets of corresponding sides that are congruent, and so then the triangles would be congruent because of side, 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 and then you could say that these angles are congruent because of CPCTC. So yeah, is that what you did? Okay, let's do it. Okay, first I'm going to write down all my vertices and just label. So -1, -2, K is 2, -1, L is -2, 0, and then I'm going to go a different color. R is 2, 3, S is 5, 2, and T is 1, 1. Okay, so this is going to be my x1, y1, x2, y2, x3, y3, third point, and then this is going to be my fourth point, my sixth point, can I not count? Okay, this is my fourth point, this is my fourth point. What is going on? I am tripping. Just forget all of that hot mess that I just wrote. Let's try this again. Rewind. Okay, x1, y1, x2, y2, x3, y2, 3. This is x4, y4, x5, y5, and x6, y6. Whew! Okay. All right. Let's go ahead and get started. So I'm going to, this was blue and that was, oh, well, that's okay. Let's go with JK first. So JK equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We substitute in. What do we get? x2 is 2 minus a -1 squared plus y2, which is -1 minus a -2 squared. Oh, that goes there. Now we simplify. Those are positive. Those are positive. 2 plus 1 is 3. So we have 3 squared plus -1 plus 2 is 1 squared. Ends up being square root of 9 plus 1, which is JK is equal to the square root of 10. So we're asking ourselves, is there a squared number that's a factor of 10? 2 times 5? No, neither of those are squared numbers. So that's it. That's an exact form. Now we're going to go to the next one. So we know JK is a square root of 10. Let's go to JL. So JL is equal to the x3 minus x1 squared plus y3 minus y1 squared equals, then we just substitute in. Whoops, sorry about that. What do we have? x3 is -2 minus x1 is -1. That's squared plus y3 is 0 minus y1 -2 squared equals, and then we have 2 negatives are a positive, 2 negatives are a positive. We're simplifying. -2 plus 1 would just be -1 squared, right? Plus 0 plus 2 would be 2 squared. -1 times -1 would just be 1. Plus 2 times 2 would be 4. So we get, what, the square root of 5? JL is equal to the square root of 5. Okay, and that's an exact form as well. Okay, so JK, JL, now we need to do KL. So KL is going to be what? 3 and 2, so x3 minus x2 squared plus y3 minus y2 squared. We substitute in. We get x3 is -2 minus x1 would be -1 squared plus y3 would be 0 minus y1, which is, no, doggone it, I did the wrong one again. x3, x2, okay. It should be -2 minus 2. Man. Okay, why do I keep messing up? All right, okay, so it's, let's do this start again. x3 is -2 minus x2 is 2. That's what it's supposed to be. And then y3 is 0 minus y2, which is -1. Okay, whew, got it. All right, now we simplify. Okay, so -2 minus 2 is -4 squared plus those two negatives become positive, which is 1 squared. So that ends up being 4 to -4. Negative times a negative is a positive. 4 times 4 is 16. Plus 1 times 1 is 1. So we end up with KL equaling the square root of 17. And that is in simplified form as well. So that's great. So we have our 3 sides here. And now we just need to do the other triangle's 3 sides. Okay? So let's start with our S. That's the square root of x5 minus x4 squared plus y5 minus y4 squared. Then we substitute. Okay, hopefully I do this correctly. That's going to be 5 minus 2 squared plus 2 y5 minus y4, 2 minus 3 squared. Okay, that double check, make sure I did that right. 5 minus 2, 2 minus 3. Okay, that's good. All right, and then just simplify 5, take away 2 is 3. So 3 squared, and then 2 take away 3 is -1. Oh, plus -1 squared. Then 3 times 3 is 9. And then negative times a negative is a positive. 1 times 1 is 1. Ooh, square root of 10. Perfect. So RS equals the square root of 10. Okay. So that's RS. Let's go to RT. Okay. So RT, what is RT? Okay, focus. It's 4 and 6. 4 and 6. Okay, so it's going to be x6 minus x4 squared plus y6 minus y4 squared equals, now we substitute, okay, x6 is 1 minus 4, which would be 2 squared, plus 1 minus 3 squared equals 1 take away 2 is -1 squared. I need a square root symbol. Plus 1 take away 3 is -2 squared, which equals a negative times a negative is a positive. So that's 1. 1 times 1 is 1 plus negative times the negative is a positive. 2 times 2 is 4. So we end up with RT equaling the square root of 5. Okay, that's great. And then what? So we did RS, RT. Now we need to do ST. So ST is, what is this? 5 and 6. So square root of x6 minus x5 squared plus y6 minus y5 squared. Now we substitute. So x6 is 1 minus, okay, it's 5. So x5 would be 5. squared plus y6 is 1 minus y5, which is 2 squared. Okay, can you see that? All right, equals square root of 1, we've got to simplify. 1 minus 5 is 4, negative 4 squared, plus 1 minus 2 is negative 1 squared. All right, negative times a negative is a positive. 4 times 4 is 16, so square root is 16, plus negative times a negative is a positive. 1 times 1 is 1, right? So we have 16 plus 1, so that means that ST is equal to the square root of 17. Okay, great. Now we have our, let's see what we got. So we have JK, square root is 10, and RS, square root of 10. So we know that those two are congruent. So JK here is congruent to RS here. Okay, what else do we have? We have JL, the square root of 5, is congruent to RT, square root of 5. Okay, so that was JL here is congruent to RT here. Okay, and then what is the other one we have? KL is equal to the square root of 17, and ST is also equal to the square root of 17. So that means that, what was it, KL right here, 1, 2, 3, is congruent to ST, 1, 2, 3, boom. So we know that these two triangles are congruent because of side, side, side. So let's go ahead and write that information. We're gonna go JK is congruent to RS. And you can kind of say distance formula. That's why we did the distance formula. Okay. And then what? JL is congruent to RT. So JL is congruent to RT. Okay. And the same thing, distance formula. I'm going to say distance formula. Substitution, a lot of simplification. Then what do we have? We have RS, square root of 10. No, I already did that one. So I did 10, I did 5. Now we got to do 17. So KL is congruent to ST and distance formula. Perfect. So now we can say that the triangles are congruent because it's side to side. We want to make sure that we are putting it in the right order. So I'm going to start here with J. It's between a 1 and a 2. So I'm going to say triangle. Oh, can you see it? I hope it's all in one frame. So triangle. Can you see that? Oh, you can't really see it. I'm going to have to go back and forth. Okay, so I'm going to say triangle. I'm going to go between the 1 and the 2. Okay, so it's going to be J, and then I'll go the way of the 1. So JKL. So triangle JKL is going to be congruent to triangle, and I have to find the angle that's between side 1 and 2, which 1 and 2 is right here is R. And then I'm going to go the direction of the 1, right? So RST. So triangle RST, and those two triangles are congruent because of, yes, side, side, side. And then what are we trying to prove? We're trying to prove that these two angles are congruent. And this is angle S and angle K. So we want to see if they're corresponding. Angle S is the second one, and angle K is the second one. So yes, they are corresponding. So I'm going to write exactly what it says up here. Angle JKL is congruent to angle RST. Angle JKL is congruent to angle RST because of CPCTC. Whew, that was a lot. So if you have all of this on your paper, you did an amazing job. Yokarikimashita, you did a wonderful job. And if there's something, then just go ahead and fix it so that your work looks exactly like my work. All right, that's it for this example. I'll see you next time. Bye.